This is a video to explain how to find for different variables using the energy of a spring is half kx squared. So let's say, folks, that we have to find, let's say we're given the energy and we're given the spring constant. We want to know how much the spring compresses by. Now this can be a very useful tool in the automotive industry to see how much springs are pressed down on and compressed by, because you want to know what size spring to put in the car when you're building it. So a question might be, if I give you the energy of a spring, let's say we get an energy value of 100 joules. Okay, let's say also that I give you a spring constant. We'll say 20 newtons per meter. Now you're going to have to go through and solve for x, the distance that this thing is stretched out. Now it's not the easiest thing because x is not by itself in there. So we're going to have to do a little bit of algebra here. And in your Algebra 1 class you learn this. You can solve for a variable such as x by itself. So x, let's see, I'm going to get rid of x. I'm going to get rid of everything but x. So divided by half k. What I do to one side, I have to do to the other. 1/2 k. Okay, so what we have here is half k canceling. And E, energy of a spring, over half k is equal to x squared. Now I don't have to solve for x squared. I have to solve for x. So let's flip it over and see what we got here. So let's clean it up a little bit. Energy of the spring over half k equals x squared. Now I'm going to say that this half can be also written as this: 2 energy of a spring over k equals x squared. Okay, all I did was, if I divide by half, it's the same as multiplying by 2. So I just made it, I cleaned it up a little bit. Okay, now to get rid of the square, okay, I got to square root both sides. And here's where it matters, guys. I'm going to get you a formula here. By the way, I can flip this around a little bit so I can have x equaling something. The square root of x squared is x. Okay, so what we have here is our, I'll put in a box or a bubble. There it is. There's our formula for finding x. Okay, x is the square root of 2 times the energy of the spring over k. If you have the energy of the spring and you have k, you can very simply find how much it will stretch or compress by. Okay, let's do one example. Okay, this is example to find x, the spring compression. I'm going to give you k value. I'm going to give you the energy of the spring. Let's call it 10,000 joules. Okay, it's going to be a heavy-duty spring here. So we have our formula: x equals square root of 2 energy of a spring over k. Okay, let's do this one out. Two E, 2 times 10,000 over k, which is 25. So I'm going to do this math under here with a calculator. Okay. 2 times 10,000, shouldn't need to do a calculator for that, but 20,000 divided by 25. So I got x is the square root of 800, just using just the numbers, which equals, I got to square root that now. $28. Now, it stretched or compressed by 28.3 meters. Okay, now this seems like a some sort of a bungee cord, because obviously on a car you're not going to get that much stretch distance. So this would be like an example for like a bungee jump. Right? It stretches by 28.3 meters. This is important when doing a bungee jump, because you don't want a spring that's going to stretch 40 meters when your jump is 30 meters. So I want to give you a little situation there. Okay, let's say you're on a bridge. Whoop, there's your bridge. And the height of the bridge is, let's say, 40 meters from here to here. If you're doing a bungee jump, whoo, off the edge. Okay, let's see, do off the edge, and then you don't know the K value, and you don't know the energy value of this spring that's going to be holding you. Well, you kind of want to know that stuff. Because you should be able to calculate how much this will stretch out based on the energy level and also the K value of the spring. Now, let's say it stretches. Let's say we ended up with a stretch distance of, like, in our other one, 28.3. Awesome. We're good. But let's say we ended up with a stretch value of 48. Well, sorry, guys. 48 is more stretch than the height of the bridge from the road. Okay, it does not work. Okay, so K value is very important when it comes to bungee jumping. Anyway, you guys, that was kind of a long video. Usually I like to break it up into two, but there it is.